The exercise is the number 2.40. The hydraulic actuator BC exerts a 1.2 kilonewtons force F on the joint at C that is parallel to the actuator and points from B toward C. Determine the components of F. And right here we have the figure. So we're going to start placing the information that the exercise is given to us within the figure. First, the hydraulic actuator BC exerts a 1.2 kilonewtons force F BC, alright? So it is crucial for us to analyze the initial point and the final point for when we're talking about vectors, right? Remember, as I always mentioned, there is two things that you have to take into consideration for when you are working with vectors, and those two things are the magnitude and the direction. All right, so if they are telling me, and this is like a hint that the exercise is given to us, that the hydraulic actuator BC, that means that this is going to be like this, right? The arrow has to be pointing towards C. Exerts a 1.2 kilonewtons force, right? So 1.2 kilonewtons. Yeah, newtons. Force F, and this vector I'm going to call it F, on the joint at C. All right. So basically they are confirming that the arrow is pointing towards C because they tell me, well, the person who, or the exercise, whatever, is telling me that the point, the crucial point, is going to be C. Right? Right here is telling me, and right here is telling me as well. That is parallel to the actuator and points from B towards C. Alright, yeah, it is telling me basically the same stuff. Determine the components of F. Alright, so I'm going to solve the exercise, and then I'm going to explain what was needed for me to solve it. Alright, first, right here we have a triangle. Alright, we have this catetus, which is equal to 0.6 meters, and this other catetus, which is equal to 0.6 plus 0.15 meters. Now, for when we're working with vectors, we can like make an equivalence between the magnitude of the force and the length of the position of the vector. All right, so let me see what we can do. Alrighty, we're going to determine first this magnitude. Sorry, what happened? Alrighty, okay, my triangle was erased, so I'm going to draw it once again. Alright, we're going to determine the length of the distance between points B and C. Right? How do I do this? Well, basically Pythagoras, I think it's called in English. So basically the vector, the magnitude of the vector RBZ, the magnitude is going to be equal to the square root of 0.6 squared plus 0.6 plus 0.15 square. Let me see that right here. So 0.6 squared plus, open parentheses, 0.6 plus 0.15 square. Righty, the magnitude is equal to 0.9604 meters. All right, now that is equivalent to the force, right? So basically I can say that 1.2 kilonewtons are going to be equivalent to 0.9604 meters, right? Now I can create this equivalence and solve the magnitude for both of the distances that we have right here and right here. All right, so basically, let me see, how can I explain this? Okay, y, going to call that value y, is equivalent to 0.75 meters, and this is in kilonewtons. And as well, I have an equivalence right here that is 0.6 meters are going to be equal to a value that I don't know, and I'm going to call it, for example, x in kilonewtons. All right, this is my way for me to solve it. There is a lot of different ways in which we can solve this exercise as well, but well, I think that it's easier at the end of the result. I'll check if there is another type of way for us to solve this exercise as well, but basically I think that this is the easiest. So this is going to be 0.75 times 1.2 divided by 0.9604. Alrighty. So basically y is equal to 0.9371 kilonewtons, and x is basically the same process but using 6. X is equal to 0.7496 kilonewtons, and that's it. Right there, guys, we have the components. Now, once again, direction, magnitude. We have the magnitude by its components, through its components, and we need the direction. So basically f, the vector f, is going to be equal to minus 0.74. I'm sorry, sir, no. And this could be confusing. Realize something. I'm going to change this to x, because I think that this could be confusing for some of you. And this I'm going to call it y. Alright, so once again, f is going to be equal to 0. Color black, 0.9371 negative along the I direction, plus, and this is positive, 0.7496 on the J direction. Now, the square root, and this is some way in which we can know that this is correct, is by looking for the magnitude of the vector, of this vector. It has to be equal to 1.2, right? The magnitude is basically the same equation that we used before, the Pythagoras. So this is going to be equal to the square root of minus, and this is something that is not necessary, but I understand that for some students it is pretty crucial to understand the symbol. So minus 0.9371 square plus 0.7496 square, 1.2. All right, it's correct. Now, basically what I did was to create a relationship, sorry, between the magnitudes of the forces and the magnitudes of the lengths. All right, basically, and this is something that you can do for when you're working with vectors, you can create a proportion between the forces and the lengths. How's that? As you can see, the magnitude of this length is equal to 0.9604 meters. So I can say that 1.2 kilonewtons are proportional or equivalent to the value that I mentioned before. And this is going to be equal, because I'm creating a relationship and equivalence, to the same stuff relating the other cathetes. For these cathetes that I have called X, and this is why I changed the name before, because I think that this, well, I don't think, actually, this is the X axis. X is proportional to the length as well for Y, that I call this. Now basically all you have to do is to solve this equation. This is only one equation, well, which we can, there is a lot of different equations right here, but there is only one part of the equation solved. So I'm going to solve the equation, for example, just for X. So what I have to do is simply to multiply this part by this, because this is dividing the X, and I'll get the result for X, and the same thing goes for the other part. And right here I have the two equivalences between the forces and the lengths, as I mentioned before. Now, for when we are talking about, once again, a vector, take into consideration magnitude and direction. So we have the magnitude through the components, and the direction is going to be given by the point 0 and the direction of X and Y. As you can see, this is a point 0 and X is towards this direction and Y towards this one, right? So this vector, which is the vector F, is going to be the resultant vector for this component and this other component, right? Why? For those of you who do not know this, a vector is basically divided by two components, talking about a 2D problem. If we are working with 3D, you have to take into consideration the other axis, which is the z-axis. But right now we're working in 2D, and for this vector you will have this component and this other component, right? Why is that? Because if I close the shape using parallel figures, I'll have the resultant vector. Now, basically, the component for x is negative because it's pointing towards the opposite direction of x positive, right? So that is why negative. The other way around is happening for y, because as you can see, it is pointing towards the same direction for the positive numbers for y, and that is why, once again, we have a positive number for y. Right? So that's it, guys. This is how you can solve this exercise. I'm sorry, once again, you have to make sure that everything is correct by placing the units. I'm sorry, the units, which is kilonewtons. Right? We're working with the force. That's it, guys. This is how you can solve this exercise.